Alright, we're going to be doing question 1a, which asks us to use the Simpsons rule twice to find the approximate area of the cross-section given. So Simpsons formula, given by a formula sheet, is area is approximately equal to h, which is the equal length of the intervals, over 3 opening brackets, distance of the first length, plus 4 times the distance of the middle length, plus the distance of the final in closing brackets. So first part here, we've got to work out that these two sections here are 0 as no measurements given. Now we're going to work out h. So h is simply the length of 10.8 divided by 4, as we've given 4 different intervals, which comes down to 2.7. So h is equal to 2.7. So now we can work out the first use of Simpsons. So area is approximately equal to 2.7 over 3, opening the brackets, the distance of the first, which was 0, plus 4 times the middle distance, which is 1.3, plus the distance of the final, which is 2.3. Close the brackets, and now by working this using our calculators, area is approximately equal to 6.75 centimeters squared, and this will be our area 1. Now to use the second use of Simpsons rule, so we use area is approximately equal to 2.7 over 3, opening bracket, so now we use the last distance as the first distance, so 2.3 plus 4 times 3.5 plus 0, closing brackets. That will give us an answer of area is approximately equal to 14.67 centimeters squared. Now this is our area 2. Now in order to find the complete area, so total area is equal to A1 plus A2. So total area is equal to 6.75 plus 14.67. Now, by adding those together, our total area will give us a distance of 21.42 centimeters squared, and the question asks us by 1 decimal place, so total area is equal to 21.4 centimeters squared.
Good man.
Alright, so for part A here, it asks us to show that angle ABC is equal to 96 degrees. So angle ABC is just up here. And to prove that it's 96 degrees, we're going to have to work out these two separate angles either side of the line here. So here we have 72 degrees, and as this is on the same line, it's an alternate angle, meaning that the angle is the same on the inside as well as the outside. So that means this is 72 degrees. On this side here, to work it out, we have to do 180 degrees minus 156 degrees, as this is 156 shown here, and a straight line is equal to 180. 180 minus 156 is equal to 24 degrees. Now if we do 72 degrees plus 24, that will give us 96 degrees. Therefore, angle ABC is equal to 96 degrees. Alright, part 2 here is asks us to calculate AC, and AC is just the angle here, length here, so this is AC, and we'll just call it X to make it easier for ourselves. So in order to find this, we're going to need the cosine rule, and the cosine rule, according to our formula sheet, is C squared equals A squared plus B squared minus 2AB cos C. And here, so C squared is obviously our angle, so it will be, we could take X squared for this, which is equal to A squared, and A squared is equal to 400 here, so 400 squared plus 500 squared minus 2 times 400 times 500 times cosine 96 degrees. Now if we put that into our calculator, it will give us 451811.3853, and as it's c squared, so c squared, that means we need to square root it, so we do 4, 5, 3, great, and then this will give us an answer of 672.169 ... and we use the ... to show our understanding that the number continues on, and then as it asks for nearest whole number, which is 672 meters. Third part asks us to find the bearing from C to A. So in order to do that, we're just gonna draw a dotted line up here to indicate to us, and then here we're going to draw 24 degrees, and how we got 24 degrees is from here, which is 156 minus 180 minus 156, which gives us 24 degrees. And then so from this 24 degrees showing alternate angle, now we need to find the angle in here, which we're going to use the sine rule for. So for the sine rule, our sine rule formula sheet is sine theta, sine A, over A equals sine B over B, and same for C. And what we do now is we do sine theta, which is the angle we're trying to find, over 400 meters is equal to sine 96 over 672. So now that we've done that, we need to times this by 400, which eliminates here, which we now take over to this side. So now sine theta is equal to 400 times sine 96 over 672. Now that's going to equal, on our calculator, 36 degrees and 17 minutes. Now that gives us the angle here, which is 36 degrees and 17 minutes. And in order to, so now we're going to add them together, so it's now 36 degrees 17 plus 24, which will give us 60 degrees 17 minutes. So we're going to do 360 minus 60 degrees 17 minutes, which gives us 299 degrees 42 minutes, which is equal to 300 rounded up, is on a 300 degree angle. So Brazil is 23 degrees south, 43 degrees west, and New Delhi is 28 degrees north and 77 degrees east. So in order to work out the difference in longitude, we're going to have to add the two longitudes together. So the two longitudes are west and east here. So we add 77 and 43, and when we put that into our calculators, it gives us a total answer of 120 degrees. So 120 degrees is the difference in longitude between our two cities. Part 2 of the question asks us to determine the time difference in Rio and New Delhi. So in order to do that, we have to understand that 15 degrees is equal to 1 hour on the map, and 120 degrees is the difference between the two countries. So in order to work out our time difference, we have to do 120 over 15 degrees, which will give us 8 hours, which means that there's an 8-hour time difference between the two countries. Part 3 of the question asks us to say what time it is in New Delhi if Jose places the call at 11 PM on Tuesday. So in order to work this out, we have to understand that so it's 11 PM for Jose, so we put 11 PM here, and there's an 8-hour time difference. So in order to work out the time, we have to put 11 plus 8, which gives us 19, So if we change that and work it from 24-hour time, 19 converts to 7 PM, but then minusing 12 hours from that, it will take us to 7 AM. So time, if in New Delhi will be 7 a.m. if Jose places the call at 11 p.m. on the Tuesday. 7 a.m. on the Wednesday. Thank you.
Yep.
Alright, so for question 2 part 1, question 2C part 1, it asks us to show the coordinates of city Y. So city Y, as we can see here, is on the 30 degrees west, but as it's on the equator coordinates is 0 degrees. So that means city Y is on coordinates of 0 degrees 30 west. 30 degrees west. Oh. So part 2, question C, asks us to show that angle AOY is approximately 45 degrees. So that's AOY is just in here. So we're given the approximate distance as 5,000 kilometers. So in order to work this out, we're going to have to use the great arc formula, which is the distance is equal to theta over 360 times 2 times pi times the radius of the Earth. So we have to. So distance given is 5,000. So that equals theta over 360 times 2 times pi, and on the formula sheet we're given the radius of the Earth, which is approximately 6,400 kilometers. So now what we're going to have to do is we're going to have to bring 360 over to the other side here. So we're going to have to do 5,000 times 360 is equal to theta times 2 times pi times 6,400. So now we'll put this in brackets to show this is all work together. So now we need to bring the brackets over to the other side. So we divide it. So we divide by the brackets. So 2 times pi times radius. Then we bring this over to the other side. So what we do one side, we have to do to the other. So we just do the same here. So now this is equal to 5,000 times 360 over 2 times pi times radius, which is equal to theta. So if we work, once we've put this into our calculator, that will give us theta will now equal 44.762 ... and we do ... to show that number continues and that we understand that, and it shows approximately 45 degrees. We round up 1 decimal place, so 7 is 5 or greater, which means we round that up 1 decimal place, which means theta is now equal to 45 degrees. Therefore, angle AOY is equal to 45 degrees.